A scatter plot is a type of graph which allows the viewer to see a representation of bivariate data, meaning data in two variables. Scatter plots can be a very useful tool to researchers, business owners, scientists, statisticians, and many other groups who wish to investigate whether or not two quantities are associated with one another or tend to show up together. Why are scatter plots and their analyses a helpful tool? Let's take a look at an example to find out. Let's say that we are children's clothing manufacturers who want to investigate whether there is a correlation between the height of humans and the length of their arm span. Knowing the answer to this question will help us create proper dimensions in the shirts we manufacture. For the purposes of this example, we will use a data set that provides information on these two quantities for a group of 20 people from the population under study. Next, we will construct the scatter plot so that we can see the data visually. Remember that just like in any graph, it should contain a title, axis labels, and should be neatly constructed. Looking at the graph, it appears that as height increases, arm span tends to increase as well. This in itself is helpful, but creating a line of best fit and calculating the correlation coefficient can give us even more information about how these two variables are related and what we can expect if we were to collect further data. A line of best fit is a line drawn through the data that best represents it. There are a few ways you can do this. You may choose to estimate this line by hand or use the linear regression formula to help calculate the exact equation of the line. For our scatter plot, the line of best fit looks like this, and the equation of this line is approximately y equals 0 and 8800ths x plus 4 and 8500ths. Knowing the formula for the line of best fit is very helpful if you wish to estimate data values that are not already part of the set. For example, if we were to consider people with heights between 54 and 3/10 and 59 and 8/10 inches, we could estimate their arm span based on our line of best fit. The second helpful piece of analysis is the correlation coefficient. This number ranges between -1 and +1 and tells us how closely associated one variable is to the other and in what direction. This value can be calculated using a formula or a digital tool. The correlation coefficient of our data is approximately 0 and 9200ths. The correlation coefficient of 0 and 9200ths means there is a strong positive association because it is very close to the highest positive correlation value of 1. It shows us that there is a strong association between a person's height and the length of their arm span, but more specifically, that as we look at heights that are taller or shorter than our data range, the arm spans would be correspondingly longer or shorter as well. All of this work tells us a lot about how the variables in question are related and could help us as we think about how to design new clothing. However, it is important to remember that correlation and causation are not the same thing. To say that longer arm spans tend to appear in humans with taller heights does not alone prove that taller heights are the cause of longer arm spans. Remember, creating and analyzing a scatter plot is a great way to understand bivariate data and what it can tell you.